Hey guys, welcome to the Arzian channel, and today I would like to show off this device but in a technical way. We go over the specs, etc. I actually put up a demonstration on my YouTube channel a while ago, so if you guys want to check it out, feel free to click up here. So, I'm also going to teach you guys and give you some tips about how to make your own Raspberry Pi 3 handheld. I hope that helps you out. And make sure not to burn your hands, because safety should be your first priority when working in such an environment. There are many hazards, so you have to watch out. So, the hardware and specs include a Raspberry Pi 3, a 3.5-inch 320 by 240 composite TFT screen from Adafruit, Nintendo DS buttons, two PSP 3000 analog sticks, but I recommend the PSP 1000 ones because they're easier to solder to. A fancy LED power switch, but it's too bulky, so I recommend a smaller one. Two USB ports for multiplayer, a Teensy toolboard for digital and analog controls, two speakers connected in series, Adafruit Power Boost 1000C, a 2500 mAh 3.7-volt battery. It's able to seamlessly switch between composite display and HDMI. And last but not least, a functional audio jack. So, moving on, let's talk about the controls. It has 14 buttons and 2 analog sticks. It has 4 shoulder buttons. It has a volume rocker, and it has a mute switch. I actually included the mute switch because if you keep the volume rocker at low, its resistance will become higher, and that's a problem because it will suck more power. So let's swiftly go over the I/O ports that are included in this build. As I mentioned before, it has a 3.5mm analog audio jack, 2 USB ports for 3 players. I removed the Ethernet port in favor of the volume rocker. And it still has the HDMI port. So, let's actually talk about the Raspberry Pi 3 board itself. I actually modified the board to be able to fit it into the handheld. I removed the camera and DSI ports using pliers. I actually advise against it because it mostly isn't needed since they are low profile already. I also desoldered the GPIO pins, which was like hell, since it was my first time doing it, and desoldering isn't easy, especially for pin headers. And as I said before, I also desoldered the Ethernet port and 2 USB ports. All the components were soldered to the test pads on the Raspberry Pi 3. I'll include the pinout alongside the circuit diagram on my BitBuild page and here as well, but if you want to download the high resolution one, just go to the BitBuild page. I actually included a Teensy toolboard in this build. I used it to build a gamepad and programmed it to be detected as a human interface device. So I soldered all the buttons and grounds to the Teensy board, and I also soldered all the analog sticks to their respective pins. Here are the pinouts. Feel free to pause the video and check it out. The code I wrote is available at my BitBuild page, and the credits are mentioned in it. But you might be like, but Arzian, why didn't you solder those to the GPIO pins of the Raspberry Pi? Well, actually, it is important to know that it's not possible to solder analog components to the GPIO pins of the Raspberry Pi without a converter, which is a pain in the butt. So I just use the Teensy tool. It's much easier. As I mentioned before in the spec sheet, the screen I used is a 3.5-inch 320 by 240 composite TFT screen from Adafruit, so the controller board I used was from Adafruit. I had to modify it to run off of 5 volts instead of 12 volts. If you have any other controller board, there probably is a way to modify it in the same way, but I have no idea about that since I only use the controller board from Adafruit. If you have any issues with screen noise or interference, what I did is just twist the composite video and ground wires. For the power, the battery I used is a lithium-ion 2500 mAh 3.7 volt battery. We need to step this up to 5 volts and be able to use this device simultaneously while charging it. So I used the Adafruit PowerBoost 1000C for my Raspberry Pi 3 build. If you're building a Raspberry Pi Zero handheld, cheaper options are available as shown here. A very important note that I really cannot stress enough is use low resistance and high quality wires. In my case, I used PC power supply wires after I messed up after closing everything up, because all kinds of power related issues popped up afterwards. I had to remove all the wires and then reroute those high quality wires to all the power consuming components. So for the audio, I've used this amplifier over here, the PAM8302A. It has a 90% efficiency when driving an 8 ohm speaker at over half a watt. I soldered 2 Nintendo DS speakers in series to it. 2x4 ohm 0.5 watt speakers in series results in 8 ohm resistance, and that's ideal for the amplifier. In the case of distortion, I advise you guys to twist the left and right audio channel wires. I tried using a USB sound card when I had issues with the sound, which was because of the low quality wires that I mentioned before, but it added a lot of resistance to the circuit and drained the battery, so I do advise against it. Don't use USB sound cards.